Welcome to the first episode of the Future Ready podcast from Siemens. We'll have lots of amazing guests and a handful of rotating hosts and moderators to cover a wide variety of topics. But today I am Nick Finberg and I'll be your moderator for all things software defined. Today we have Rainer Brehm, the Chief Technology Officer for Siemens Digital Industries, as well as the Chief Operations Officer for our automation business. Rainer, it's great to have you here, and I really appreciate you taking the time out of your busy schedule to co-host this series. But the stage is yours. What do you want to say about software defined?
I don't know whether it's the right thing to say to demystify software-defined automation, but I think everybody talks about it, and it's such an important thing because it lies the foundation for also when we move into a more adaptive autonomous production. And so I think it's about explaining what it is about, where to start, what it means, what would be the future, and how it fits also into the story around AI, which is in everybody's mouth. Yeah, so that's the reason I think it makes very much sense to have a deep dive on that topic.
Awesome. Thank you so much. Well, we're going to start off this first episode talking about kind of a high-level understanding of what is software defined and what your views are on this topic. So let's start off with that first question. Automation is kind of the backbone of industrial manufacturing. But today we hear more and more about automating the automation. What does that really mean?
If you automate today, you're writing a code, you write a program, you tell the automation what needs to be done. And maybe to start, where automation comes from. Automation is mainly done in the factory and maybe in some infrastructure projects. People which did automations and still doing automation today maybe are coming more from the electrician side. So people were doing the wiring and then doing some programming. That's the reason why how you program a PLC today is a little bit like it's a wire diagram. It's called ladder logic, and that's the way how you think and how you do that. But still, you need to say like a wire diagram. This is how it looks like, and then you're gonna test it, and then you're gonna execute it. When we say we want to automate automation, we want to automate this. We want to automate how automation is engineered and programmed. And we want to make automation much more flexible. That means we want to go away from a rule-based automation where you need to know everything up front into a more goal-driven automation and a goal-driven workflow. So that means the next level of automation is we might automate the unknown, the unpredictable, because automation is smart enough to react on certain aspects without being pre-programmed for that. And that is what we mean by to automate automation. But we also see that getting that flexibility in enables not only a much flexible automation program, but it enables a much more flexible and modular production system, which lies then the foundation for applying AI, which moves us into autonomy. So automate automation means using software-defined automation to be more flexible, but also using new technologies like digital twin and industrial AI to change the way how you connect the design phase and the production phase.
Okay, so you talked a little bit about the AI disruption and the constant change a little bit, but what's the strategic role of software-defined solutions in this shift? Why is it so relevant?
Well, in the past, normally our customer says, well, I did a start of production, now it works. And then never change a running system. So keep it stable, don't do anything, keep it running. Even so far, don't switch off the power because we don't know whether it starts again. So don't do anything because it works. And today, if you look at a software development, you're constantly changing. You talk about DevOps. You're doing something and you're testing it. You have a full delivery pipeline and the customer is using it to getting feedback. So what you want to go in a continuous improvement. And that's important for our customers because they need to test out also what they produce, how it fit, how it works, how to get more productivity, how it fits to their customer demands. So you need to be much more agile in trying out new things and going away from a never change a running system in constantly improve, adapt, modify your system. And there, it cannot be done in changing the hardware all the time. That changes need to be fast. And software development is very fast. You change a line of code, and then you deploy it and it runs. And so a lot of these new features and functionality our customer needs will be software defined. And you see that not only in the manufacturing space or production space, you see that everywhere. And look at how televisions look like today. Television has a lot of software built in, and you have apps, and you can change apps. And if you have a new streaming a thing comes up, you're gonna have this new app and stream it. The same looks at cars. Classical cars are more software defined. You get updates on your car, you get new functionality in your car. So we see that in a lot of devices, and that also means now we move more into software defined production, because the production is building those products I just talked about.
Okay. So when we talk about software defined everything, what exactly does that cover? Is there a limit?
I wish there would be no limit and you can do everything with software. But I'm also realistic. Automation plays in the interaction of the physical world and the digital world. And my wish would be, for example, a software-defined everything could mean you can download, or even a system is smart enough to fulfill any action. But being now realistic, if there's a robot and you want to grip something, and you need a gripper, and the gripper need to fit to the thing you want to grip from a dimension perspective, from a weight perspective. So if I make everything software defined and the mechanics simply doesn't fit, I think it's hard to do software defined. So yes, there are limitations for sure, but I think where we are and where the future is, we not at all have leveraged the potentials of software defined in the automation space, and the software defined also goes not only kind of from the mechanical perspective that we have much more functionality in software. It also goes a little bit into the topic around how you do it. I was just mentioning that in the past the automation was mainly done by electrician. So if you now look at the markets, and if I want to have an electrician at home because something is not working anymore, I'm on the waiting list. So they are not around the corner and say, now I do it. Probably I find more software developers than electrician currently. So that means also the way how automation will be done will be different. It's not the electrician mainly anymore. There will be a lot of software developers which are writing software for automation, which are writing software for the real world, which are writing software for physical devices. And we need to make this physical world accessible to software developers, like they can do software development for all kind of apps and programs they're writing. And that excites me because, you can create real world impact in the physical world, and we make it accessible to a broad community of software developers. I mean, that's really great. But in order to do that, we also need to enable the tools we have, like software developers want to work. And that's another topic around software-defined automation. Not only the execution of the task, it's also the engineering of the task.
Yeah, would you mind going into that in a little bit more detail? What exactly does that entail, building out that infrastructure?
Well, that means on the engineering side, how you do modern software engineering. You basically you're programming it, then you store it in a repository. You have version control. Then if you want to deploy something, you have a build, you test, and then you do a kind of on a DevOps. You're going directly in production. So you have a completely different development, repository, deployment mechanisms, like you have maybe today on an automation world. And I think we need to adapt that and make it maybe even command line first. And a lot of programming is done automatically anyway. So no, it's not somebody writing a code anymore. Maybe it's an agent or somebody else, who's writing the code. So therefore, we need to adapt that into, we do it today. So GitHub, for example, or GitLab is a repository, and it needs to be used not only for software development, but also for automation. And the same counts for deployment pipelines. You want to deploy topics in a mass deployment, like you do, for example, today. You write an app for a phone and then deploy it massively. So we need to get this environment also into the automation world. I mean, number one. Then we need to leverage data much more, because I think currently the data is mainly used in the automation side to control something. That's a primary task to do something. You control a machine or you do something. You read inputs, you do an action, and then you write it to the outputs. But this data have a secondary use. You can use them to analyze it, what's going wrong. You can use this data to further optimize. So we need to also make this data available. Yeah, this is also something we need to change if we will go into software-defined automation. And then on the execution part, currently a lot of automation is done in a very closed embedded system. And I think we need to more decouple that inference or that execution of the automation task. That workload can to different platforms. It can be still embedded. It can run on an industrial PC. It can run on a virtual machine on an industrial PC. It can run on a virtual machine on a local server, or it runs somehow in the cloud. So there is also a detachment of that workload from the hardware it runs on, and that accounts for classical PLC workload, as for AI inference, as for maybe topics around operation software like a SCADA system and others.
Thinking about where to augment and how to scale, that's super interesting. And it rings so true for the design side of production as well. But I think we're going to take a break here for now, and we'll be back with the next episode to pick up on some advice for companies looking at or already on the software-defined journey. For our audience, be sure to subscribe so you don't miss it. And until then, you can check out the links in the description to learn more about software-defined.